Hello, good afternoon, everyone, and welcome to another session of Asset Colloquium here. Today, we have a very prominent aviation expert in safety, Shri P.S. Ganapathy. As you can see, he had a very vast experience, 58 years, and he has been working in Air India for 30 years as a safety manager. And after that, he spent almost 2 decades, or maybe 1.5 decades, 15 years in Middle East, helping Oman and other Middle East airline industries for safety and related issues. To formally introduce him, as I've already mentioned, he has a very vast experiences as an aviation consultant. He worked 33 years in Air India as a manager regulatory compliance in Oman, and also for safety regulations. And he has contributed immensely in writing safety manuals, the one which is followed for aviation safety and what the aircraft maintenance as well as flying crew. For pilots and things, what to do in emergencies and what not, and what kind of things. I'm very sure that he will give us an extensive overview of all the things we have done, and it will help us appreciate the improvements in airline safety records and things which over the last 5 or 6 decades, which he has been involved in. I welcome Mr. Ganapathy to give a lecture.
Thank you very much. Are you able to hear me? Sir, you can come in the front, sir. Plenty of seats are vacant. At the outset, I would like to offer my sincere gratitude and thanks to the alumni of TFR for inviting me to share my experience on the subject of advancements, amazing advances in the aviation technology. What are the contributions made by the aviation technology in the important field of safety, efficiency, and reliability, above all, the passenger comfort? Basically, before joining Air India, I did my M.Sc in mathematics and statistics. Therefore, in my presentation, 1 or 2 places, I will prove my statement through mathematics. That is, you are all scientists of high intelligence. You will prove it by means of a theorem and practical demonstration. Whereas I am not as literate as you are, and I can only prove 1 + 1 is 2, which you cannot deny. Coming back to that, the father of civil aviation is undoubtedly Sri J.R.D. Tata, who also piloted the first commercial flight on the 15th of October, 1932, between Karachi and Bombay. His slogan is the golden quote, and one of his golden quotes is that one must forever strive for excellence or even perfection in any task, however small, but never be satisfied with the second best. This is the quote of excellence. You all know that civil aviation is governed by the International Civil Aviation Organization, that is called ICAO, which sets up the objectives for the international aviation. The 4 governing principles of ICAO is, number 1 is safety, number 2 is efficiency, number 3 is reliability, last but not least is comfortable to the passengers so that they will be satisfied with the quality of product that they get after paying a huge cost. My today's talk is going to focus how the technology is going to contribute on all the 4 aspects of civil aviation. That is safety and efficiency, all those things. For me, aviation is exciting. Secondly, it's growth-oriented. Last but not least, it is compliance-focused. Everything has to be by regulation. Nothing is outside the regulation. In view of the compliance focus, you will see that civil aviation enjoys the best safety record, which you will see how the technology has contributed to this. When I say aviation is exciting, the art of or science of flying aircraft, the design, production, and maintenance. For me, aviation means, I told you, ECG. If you put A is 1, Z is 26, V is 22, I is 9. If you add aviation, it will come to 91. If you code G is 7, W is 23, growth is 91. Thirdly, compliance. C is 3, O is 15, M is 13. You add, it will come to 91. Therefore, I have proved that aviation revolves around these three characteristics, which nobody can deny. You can't deny because no, I am not a scientist, but I proved it. Now I will prove it practically how this is exciting. The first flight which J.R.D. Tata flew was a push-mouth aircraft, VT single engine, VT ADN, Karachi to Bombay. It landed in Juhu airstrip, hardly carrying 3 passengers, and 930 kilograms is the weight. And this flight took 7 hours, Karachi to Bombay, with 2 stopovers, one at Ahmedabad and second at Surat. And this flight was filled by bullock carts at the Ahmedabad airport. 2 bullock carts by Burma Shell who carried the fuel and filled the petrol or the fuel to this flight. In the March 1948, Air India introduced a Lockheed 1048. That his range is about 4,200 kilometers, 51 to 81 passengers it carries, and the takeoff weight is 47,000 kilograms. From 930 to 47 kilograms you have come. Then in 1970s, 747-200 was introduced, which carries a passenger of about 400 passengers, and non-stop, it can cover 9,000 kilometers, and the max takeoff weight is 350,000 kilograms. The latest Airbus 380, which is supposed to carry the most number of passengers, 600 passengers, max takeoff weight is 5,60,450 kilograms. This is the exciting growth of 3 passengers to 600 passengers, 932, and today flights are non-stop flight is going on. This is the first flight cockpit, VT ADN. And the same aircraft, he flew it in after 50th Golden Jubilee. Again, he flew, J.R.D. Tata flew Karachi to Bombay. Today, the world is looking for this flight. This flight, you will be able to see 2 sunrises. Qantas is going to operate ultra-long flights. Launch date is mid-2026. This will be Airbus A350-1000. It can fly 19 hours to 22 hours non-stop. That is because of the technology. The technology guarantees fuel efficiency and also safety for operating this flight. If the fuel efficiency is down, the cost of the operating is very, very high. Today, in airline industry, more than 33% of the cost is fuel. Therefore, if the fuel is not efficiently planned, the cost effectiveness will be very high and no passenger will be able to afford a small flight. That's why Concorde died completely, because the cost of Concorde operation is 4 times more than the normal jet operation. Civil aviation is totally regulated compared to the road transport. Today, you will see in the road, at least 25% of the people do not have driving license, but they will drive. There is no rule. Opposite directions you will come. You have to wear helmet. No. One scooter may only 2 people. 5 people will go. That is called the road transport. Here, everything is regulated. The crew is licensed. Maintenance crew is licensed. AMEs, pilot is licensed. And he has to undergo the initial training, recurrent training every 1 year. I did my M.Sc in mathematics in 1966. I don't have to demonstrate my knowledge to anybody after my degree. Whereas pilot is not like that. Every first year, he has to undergo the technical course and simulator course. And supposing he is away for 2 months leave, he cannot come and sit in the aeroplane. He has to undergo a ground refresher and also a simulator. That is the safety point of, that's a regulation. And he has to also all those things. Aircraft maintenance certificate of airworthiness. Every aircraft has to be certified by the DGCA representative that this aircraft is healthy, and the certificate of airworthiness is valid for 1 year. Every year they have to renew the certificate of airworthiness. You have got the checks of A, B, C, D. That I will explain to you. And every training organization have to have the approval. They will inspect the facility, they will inspect the quality of the instructors, designation, and qualifications. Then original equipment manufacturers who are all OEM approved by the local regulatory authorities. Then what is the minimum fuel has to be carried in the fuel, flight? What are the minima? Supposing a pilot is coming to operate to land, if he is not qualified to do category 2 operation in Delhi, the weather is below 500 feet, the visibility is below 500 meters, he cannot land. He has to go on because he has not trained for the category 2, which I will explain to you later on. Operations manuals have to be written before a flight starts. You must have a maintenance manual. These are all the requirements of the regulation. Why I am telling you is completely airport has to be certified, whether the airport is following the international regulations, runway length, stopway, clearway, everything. Because of this, civil aviation is totally regulated and you're enjoying the safety record. Maintenance check, every aircraft has to undergo A check, which is in 400 to 600 hours. Did any lorry or bus or a taxi undergoes a check? It goes on till it grounds on its own. No check. I have seen in India, there is no, what is it? Glass, like a panel, glass panel, right side and left side. People will drive without the glass panel because you don't have to require gear. All you require in India is a brake and accelerator. In Muscat, when I went for Muscat license, first day I failed, first test. Why I failed? The inspector of the Muscat road inspector sat in my car. While sitting in the car, he put the glass on a closed mode. Therefore, then I started. I went up to there. He failed because I did not check whether the glass is opened or not. That is the amount of rigidity. Then similarly, B check is to be done every 6 to 8 months. Every aircraft has to undergo the B check. C check has to undergo every 24 months. And the major D check of the complete overhauling of the including seat removal has been performed every 6 years. The first check takes 25 hours. Second one, 440 hours, 1,000 hours, and 50,000 hours. These are all the maintenance checks requirement on regulations. This is the growth of the civil aviation. If you see the last 50 years, the growth has gone from 49 to 71.5 million flight hours, and the departures has gone to 31.3. If you see 39 million to 71 million, almost doubled in 20 years, the growth. Similarly, the flight of departures also from 19 million to 31 million, civil aviation is continuously growing. If you see the Indian statistics, the passenger growth is 103 million to 220 million, in almost doubled in 10 years. Similarly, the airports 74 to 157, almost 3 times, and India is going to witness 350 to 400 airports in 2047. That is the growth projection. Last one is, now we are going to see how technology contributed to the 4 objectives of ICAO: safety, efficiency, reliability, and passenger comfort. Now, these are all the, Now, the first you take the safety improvements. If you take 1974 to 1983, if you take there, here, if you see here, you have almost 3.5 accident takes place per million departures. It has come down to almost 1. Therefore, this is in the total. That is the total. Next one is the all accident rate is this one. Next one is hull loss, means if an aircraft meets with an accident, it cannot be repaired, completely damaged. Therefore, it is total loss. That is called hull loss. And third one is a fatal. All the 3. The third curve is fatal. If you see here, accident rate has reduced by 45%, hull loss is 58, and fatal accident 68, even though the departures are increasing by 25%, but all the accident rate has declined over a period of about 50 years. That is primarily due to technology. This is one of the examples of 40% of the most fatal accidents are happening in 2% of the flight time. takeoff and landing is the most critical phases. Therefore, the technology has applied more importantly how to prevent landing accident to a great extent, like runway extension, loss of flight and control. All those things are primarily focused to eliminate the landing accidents or reduce the landing accidents as much as possible. Now, if you see this flight, in 1968 to 1977, one passenger died out of the 350 people, 350,000 boarding. In 2008, 1 per 7.9 million. That is the safety record. In 2018 to 2022, 13.4 million passenger travel only, you see one death. Today in Bombay, you see road, every day you see in India, 20 deaths in each district. That is the, here 2020 to 4 years, 13.5 million passenger boarding, 400% increase. What it means is the chance of dying during an air journey keeps dropping by about 7% annually, continues to go down by a factor of 2 every decade. 2% it comes down on the accident rate. That is primarily attributable to technology. That's why technological advancement doubled the computing power of ships approximately every 18 months. In this context, commercial air travel has become about twice as safe each decade since the late 1990s. One of the contributors for the safety trend is use of technology by manufacturers of aircraft and engines, which I am going to prove in the next one. This is the first generation aircraft, which is called 1952, dials and gauges in the cockpit, early introduction of the auto flight system. That is the first Caravelle and other, if you see the aircraft, Boeing 707, 320, all of them, generation 1 aircraft. Generation 2, if you see, more integrated auto flight, auto throttle, autopilot, all those things are introduced in the second generation aircraft. That is becoming, if you see, Boeing 727, Boeing 737, Boeing 747. Third generation starts the glass. What is that? You want auto? This is second generation? See, this is autopilot and auto throttle system. Auto throttle system monitors the engine parameters and it tells the pilot the engine EPR is going on or not, what he should do. Automatically, he is able to make the adjustment because that is in second generation. Then third generation, you will see glass cockpit and flight management system. Glass cockpit and flight management system, you will be able to see the improved navigation performance, electronic cockpit system, everything digitalized completely, and also terrain avoidance system. That means when the terrain is there, it will give a warning, like in the car also you will have pull up, or pull down, and the terrain warning will come to avoid controlled flight into terrain. That is in the generation 3 aircraft. Last generation is fly-by-wire. Here, flight envelopes protection. Pilot cannot exceed the limitation. If he exceeds the altitude limitation or the wind limitations or the speed limitation, it will give a warning for him so that he's come back to his normal checklist. Therefore, this is generation number 4 aircraft, which is preventing the loss of control in flight because it doesn't allow him to exceed the limitation. It gives a warning. That is because of the technology. Advances in technology has helped. That's why if you see the first generation aircraft, 2.45 accident per million departure. Now if you go almost 0, on 0.3, these are all Airbus and the Boeing slides. Therefore, if you see here completely, if you see technology, second technology 1.11, third one 0.11, third one, last one is 0.3 on the fatal. That is why if you see almost 100% decrease in the accident from the generation, if you compare generation 1 to generation 4. If you take same thing about hull loss, same thing, 4.48 to 0.14, again, 100% decrease in the accidents because of the generation of aircraft technology. All the three he has shown it. Now, the most important thing which you saw, landing and approach lot of accidents are taking place. If you see here, the first generation aircraft, second generation to third generation, 87% reduction is in the third. And the third one, in the loss of control in flight, 90% is reduction from generation 3 to generation 4 aircraft. That is a remarkable technological advancement has enabled the aircraft manufacturers and engine manufacturers to use the technology so that flying becomes more safer and safer. This control to flight into terrain, again, I'm showing that same terrain awareness warning system. I will show you one of the, because if I start explaining each one system, we conduct a class for each system 3 hours. Pilot should know what is TCAS, what is terrain. Each one we will operate. The ground course goes to at least 2 months. Therefore, I will not be able to explain everything in detail in the 1 hour time. I am just only telling you controlled flight into terrain has come down practically to zero. It is very glad to know in 2023, there was not a single controlled flight accident in this globally. And this is again hull loss. Everything has come down. If you see here, 87% compared to generation 2 aircraft and the control to flight into terrain. And similarly, loss of control in flight, if you take fatal, again, it is 90% come down. Same thing, hull loss. So I am comparing fatal and the hull loss, all of them generation aircraft, third generation, second generation, and first generation aircraft. This is the runway excursion, means the pilot is not able to stop the aircraft in time. It goes beyond the runway. Therefore, number of accidents have taken place because of runway excursion. Therefore, the technology has brought a new thing called longitudinal runway excursions related to aircraft energy management. An improvement in the RE accident rate should be expected with the introduction of runway overrun protection system. The Airbus aircraft has already introduced this. This will give a warning to the pilot that the runway is short, you to apply the brakes and stop it. Or if you're exceeding that wet runway or runway, it will ask him to decelerate and put the thrust reverser so that he will stop the aeroplane. The warning will come to him. This is same thing on that. I will just show you the picture here. See here, the runway overrun system, the runway overrun, he will get runway short. That picture will come. And here, max reverse so that you stop the aeroplane before it exceeds going to the runway. Maybe if that point of time, there may be some damage is there. Instead of completely the aircraft becoming completely lost, you will be able to save by stopping with a minor damage. Or if he is able to do immediately, you can fully stop the aeroplane with a minimum number of damage. That is, these are all the systems available because of technology. This is a traffic collision avoidance system is one of the systems which alerts the pilot when the aircraft is coming very close. Mid-air collision has been avoided number of times because of the pilot is able to get the alert. Somebody is coming. Again, the picture says there are 2 zones. First, the traffic advisory, if it is close to 10 miles, it will give a traffic advisory that some aircraft is coming to you, be aware. But if he is not able to do, resolution advisory will come, which is in 5 miles. He has to immediately action. An warning will come and lights also will come, pull up or pull down, depending upon that. This is the zone. Aircraft intruder is coming. On 20 to 48 seconds, that alarm will be there. And here 15 to 30, resolution advisor comes, sorry. The resolution advisory comes, pilot is in danger. Therefore, he has to immediately take action without questioning whether it is wrong or right, go up or go down, depending upon the instructions that he will get in the oral warning. This is the traffic collision avoidance system has developed, completely eliminate the mid-air collision. This electronic centralized aircraft monitoring system in the aircraft cockpit, if any system is not malfunctioning, immediately it will give a warning. The co-pilot will be able to check what is the reason. He will be monitoring the aeroplane. The other man will be able to check before it becomes a catastrophe. That is being available in the A320 family. Boeing also has got a similar system. They call it engine indicating and crew alerting system. This also alerts the crew when supposing a passenger door is given, cargo door is opened or something, immediately a light warning will come. Even if passenger smokes in the toilet, a smoke warning system will come. Immediately, the cabin crew will go asking you to stop it. Therefore, these warning systems are available in the cockpit. Now, this is the one which I just wanted to explain to you. pilots, the low visibility operation, now you will see in Delhi, everybody is calling, many flights are being diverted below category 2, below category 3. The category 2 operation, the low visibility operation requires 3 components. One is the airport should be suitable. The manufacturer, the aircraft must certify this has got all the system that is required. Thirdly, the pilot has to be trained. Unless these 3 things are there, you will not be qualified to operate. Therefore, what do you mean? Say 200 feet means when the pilot comes and lands on 200 feet, he is able to see the runway, he can land. That is called category 1. That means next person less than 200, 100 feet. Next line is 200 feet, he will come. If he sees that if he is qualified on category 2, he will be able to come up to 100. Then he will see the runway. If you're qualified to category 3, he can come up to 50 feet. And if he sees the runway in the 50 feet, he will land. If he is not able to see, he will divert or go around and wait for some improvement depending upon the fuel. And final decision he will take, if the fuel is not enough for him to go to the alternate, he will immediately take action. Therefore, this is called category 2, category 1, and category 3C is completely without any head-up display. The pilot will not be able to see anything. He will just see the cockpit instrument that's called head-up display. In North America and South America, if you go, winter May, you will not be able to see the runway. Only the cockpit display will show. Blindly he will go and land. But we have not come to that stage. We have up to category 3B. And that one, visibility is also there. The category operation based on the decision height, where you have to make a decision, and the visibility is 500 kilometers, 550 for Cat 1, and Cat 2 is 350, Cat 3 is 200 meters. 200 meters visibility is enough, he can land. If 50 meters visibility, if a man is qualified on category 3B, he will be able to see only 50 feet, he can still land. Therefore, both the pilot and the co-pilot has to be qualified on category 2. If one pilot is category 2, one pilot is category 1, that flight is only considered as category 1. Both have to be qualified on board. That's called low visibility operation. In India, there are only 5 airports which has got category 3. When we come to the next one, first goal is safety, that has contributed. Now we come to efficiency. When you are planning for efficiency, we have got to see the global industry requirement. In 2009, the entire aviation industry committed to high-level climate action goals. Now, today, many countries are going to take action. If your carbon emission exceeds certain limits, you have to pay a heavy fine. Similarly, in London and Heathrow airports and all, if the noise limitation gives more, supposing approved noise is 105 decibels on landing. If some pilots lands with 110 decibels, there will be marked. And in Air India, we have paid more than $1 million or 1 million pounds to UK for noise violations. It does happen, but sometimes but therefore, why they are doing it? They don't want noise, because after 11 o'clock, the airport itself is closed in Europe. That's why all of the India coming 24/7, anybody can land in India. There is no curfew time in India. We are a free democratic country. Majority of the European countries, beyond 11 o'clock, no scheduled flights will come. And if you are non-scheduled flight, special permission is required. Therefore, improving the fuel efficiency by 1.5% and achieving net carbon. In addition to that, our carbon emission also should come down. That is the goal. Reducing the global net aviation carbon emission by 50%. That is the ICAO goal. By 2050, the present carbon emission should be reduced by 50%. 100% is not possible. Slowly, they have set a target of 50%. And then focus on the green aircraft technology. These are all the challenging trends which the manufacturers take into consideration when we are achieving the fuel efficiency. But the airline industry is contributing to about 2.5% of the global emission. Some people say it is more than 2.5, but ICAO is defined as 2.5. For the time being, I'm not able to. Okay, I will just show you. Next slide, it will come. Achieving these objectives require innovation, which can be addressed by technology. This is the first flight of 1903, which is just 120 feet. The Wright brothers flew, and this one is Boeing 87. The current one 18 hours and 40 minutes. This is the Singapore Airlines flight between Singapore to New York, the current one. The one which I showed was in 2026, it is going to be 19 hours and 22. Now, coming back to your point, efficiency upgrades. Manufacturers have already, see, one of the important things is if the aircraft weighs high, the fuel consumption is also high. When the fuel consumption is high, emission is also high. Therefore, you have to reduce the fuel consumption, thereby you will also reduce the carbon. Therefore, one of the reasons they have to, manufacturers have already made later models of planes efficient with blended wing and leading to reduction in the induced lag. The next slide, if you see, normally earlier aeroplane, aluminum was used more than about 70%. Currently, aluminum has been reduced to 20% and carbon has been increased. Carbon lamination has increased. The blue color has increased 70%. As a result of that, lightweight and strength is also more. Performance is also better. The fuel reduction also automatically takes place because of the weight reduction. That is, and also carbon sandwich, fiberglass, aluminum. And this is the, if you take the 777-200 in 1970s, if you see aluminum was 70%. Aluminum was 70%, that aluminum has come to 21%. The carbon, 7%. Only carbon CA power is only 7. It has become now 50%. If you see here, the carbon fiber reinforced plastics, which are lightweight and have high strength of performance, are materials used to achieve larger fan sizes. Structural guide vanes further reduce the weight by integrating the vane and structural components. As a result of that, if you see the major one is carbon has increased to 53. Now, over a period of time, in the 747, which was used in 1970s, and what is 787, if you see the transformation here, you will come to know automatically the complete one is here 50%, and here almost 70% was there in 747. As a result of that, you are able to slowly reducing that. Major one is coming, next slide. Engine manufacturers, CFM said, that is CF International, that is a French collaborated Europe, French and Anglo-Indians having the engine manufacturers. They are producing leading edge aviation propulsion, which generates 50%, 15% less CO2. That engine, and up to 15% more fuel efficient. That engine, that is CFM International. Pratt & Whitney is producing geared turbofan. The gearbox between the fan and the low pressure spool allows each to rotate at its optimal speed, and it will reduce 16% of the fuel and quieter than when compared to the older variants. The engine manufacturers also attempting to reduce the fuel consumption and increase the fuel efficiency. And the third engine manufacturer is Rolls-Royce. He is going to do it 100%. He wants to achieve by using SAF, that is sustainable aviation fuel. That is going to be the future fuel which is going to be used, but it will take time, which I will explain to you in the next slides. Sustainable aviation fuel is the real thing which can completely eliminate the CO2, but it will take a longer time. There is a time limit is there. That is, the Rolls-Royce has 140 fan diameter and geared fan enabling, and claimed to offer 25% saving on the fuel in each flight. This engine, which they are planning, will have completely 25% fuel saving will be there. On a lightweight composite, what you have said, fan blades, geared up to turbofans, composters, extreme high temperature tolerant, lightweight materials, improved fuel design, 3D printing, which I will explain to you later. 3D printing means it's the three-dimensional design, and you can usually manufacture whatever the parts, but you must have an approval to have the 3D printing parts by the local regulatory authorities. Because, yes, you got it? Okay. And one goal is more efficient engines for the future. Can you come here in the front, please? Huh? Yes, yes. Yes, yes, yes. Composite material reduces the weight of the aeroplane. So, more than about 50% of the weight is reduced if you instead of aluminum, if you use. As a result of that, my fuel consumption improves if I use the composite material. And it is also high performance also for the engines. Maybe. And this is some of the Safran engine, 2 counter-rotating unsorted fans. Research suggests 30% reduction in fuel burn and CO2 emissions. And downside is the cruise speed affecting because of the less cruise speed, ATC management, because he will be longer day occupying the space. Therefore, the ATC management will be slightly strained. ATC will have a strain if the low speed at a high altitudes. And then external and internal noise, this aircraft. Counter-rotating and fans have significant improvements in propulsion efficiency, weight savings, and enhanced thrust-to-weight ratio, making them particularly beneficial in the design of efficient, quieter, and powerful aircraft engines. It's a purple. Next one is, this is a radar. This is one of the Air Force management is earlier, before 1982, when you're flying between vertically, all the aircraft has to be separated by 2,000 feet. That was the rule. When I joined in Air India in 1966 onwards, they found out number of airspace is not available. Because of that, 1982, they came with a concept called reduced vertical separation minimum. About 29,000, most of the jet airplanes globally fly about 29,000 up to 41,000. Therefore, what they have done is all the RVSM trained crew on the RVSM certified aircraft will have to have only 1,000 feet of separation. They don't require to have. As a result of that, when only 6 aircraft is occupying the airspace, as a result of the RVSM concept of the technology, they were able to provide 14 aircraft in managing the sky at the same time without affecting the safety. Because the crew are trained, if he is not able to non-compliance of RVSM, he will leave the airspace and he will maintain the 2,000 feet. That's the standard procedure. Now, these are all the requirements for that aircraft: 2 independent altitude measure, alerting system, automatic altitude hold system, SSR transponder. What are the requirements for the RVSM certified aeroplane? They have to, if any one of there is a separate MEL. If any one of the system is not operating, the aircraft, even though certified for RVSM, cannot operate on that aeroplane because one of the MELSM is not fulfilled. That's a rigid regulation. Pilot will not operate on the RVSM. He will go by the 2,000 feet margin. Next, we go to the reliability. This is primarily advanced materials are being now used. Modern aircraft made of composite materials such as carbon, fiberglass, and metal alloys. These materials help engineers lighter and stronger and more durable structures. One of the technology. And you all heard the black box. The CVR is a cockpit voice recording system. And the other one is the DFDR. That is digital flight data recorder. This continuously monitors as per the regulation 88 parameters: altitude, speed, and whatever you lay, you have got all the parameters. These are all analyzed by the software team of the company, and they find out what are the maintenance area where this kind of exceedance takes. So, for example, pilot, since I come from the operation department, we use this rate of climb, so rate of descent is 500 feet per minute. Supposing a pilot has done rate of climb is 700 feet, 800 feet, we will analyze and call the pilot. We have analyzed the DFDR readings. Most of your flights, your rate of descent is very, very high, more than the limit setup. They counsel him. They will not use him for any penalized action, only for counseling. Similarly, hard landing. If a pilot makes a hard landing, all these things recorded in the DFDR. Similarly, all the maintenance system, sensor, all the data are analyzed and find out how the fatigueness of the particular component affects. Therefore, they will be able to replace those fatigued components by means of timely analysis of the DFR data. Maintenance and repair overall organization use this aircraft management, supply chain management, optimum downtime. Because of the technology is available, they are able to use all of the data so that they will be able to maintain required spares, because spares are very costly. Therefore, they will know which spares are more required, which are less required. Sir, another 20 minutes I can take? Okay. So I will just go. This is one of the latest one augmented flight training. Because if you come for the augmented reality training, which is already there in Thakur Institute of Aviation College for maintenance people, it tells you what is a snag and how do you repair it. Automatically gives all. Now all of you have known this Alexa box, Google. You answer what is the capital of New Delhi, it answers. Who is the Prime Minister of India, it answers. How? I'm just telling you. Therefore, the latest one is ChatGPT. You can do anything. The other day, I wanted to write a speech for somebody else. I have no time. I went to ChatGPT. Could you please give a small speech on the subject matter a chief guest has to speak? It immediately gives me about one page. You take 2 minutes to correct it and use it. Because the technology has improved so well that you will be able to get everything. Now, today, nobody goes outside, everything with the mobile. If you want to eat something, I want to cook. My daughter says, 2 minutes, it will come. By the time I get there, outside say, dosa will come or vada pav will come or whatever it is in 2 minutes. Therefore, technology has made man lazy. This augmented reality is really an excellent tool for training. It tells what you have to do, and the maintenance technicians embrace this technology because it helps him to identify the fault and immediate corrective action. Predictive maintenance, lot of data are coming, sensors are available in the aircraft. It continuously monitors a particular equipment, particular system is not going to function normally. It predicts, oh, it will be fatigued in the next landing. Before it occurs, it warns the maintenance crew. Therefore, before the actual fatigue takes place, he immediately, when the aircraft lands, he makes the repair and immediately. So the predictive maintenance helps to identify in a proactive manner what are the faults likely to come. For example, in Air India, it's been because of this, the communication system, a particular equipment is not working. It's immediately communicated to the maintenance from New York to Bombay. As soon as in Bombay, the ground time is 2 hours for the aircraft to go the next flight. Within the 2 hours, because he's already got all the information about that during the cost system or the maintenance system, he will be able to keep everything ready. The moment the aircraft comes, normally, if that information is not available, it will take 4 hours. Therefore, he will be able to complete it in 2 hours. By continuously monitoring the aircraft system, component structures, proactively, downtime is reduced, enduring uninterrupted operations. This is 3D printing, I told you, additive manufacturing technology, including 3D printing, have revolutionized the production of parts in aviation. Majority of the parts, you can do it on a 3D printing as per the approval of the DGCA. Not all of them are approved. I will show you it in the final slide, what are the parts which are approved for the 3D printing, so that you don't have to wait for the manufacturers to send it. It will take a longer time. Therefore, you will be able to use the 3D printing technology so that you will be able to save a lot of time and cost. Passenger comfort, I don't have to tell you. Today, you just walk in with a mobile right up to the aircraft. Web check-in, electronic boarding card, biometrics. In Abu Dhabi, if you just stand in the no passport even seen, everything is done on the smart travel technology. This is one of the, and secondly, in-flight entertainment, internet, everything is available. And this is a 5-star luxury. There's nothing to do with technology, but aircraft have become so technology. Now the challenge for the technology is this. Aviation is now entering the 4th revolution. The first one was made aircraft to fly. The second one focused on safety. Everybody is being, now aircraft has become safer and safer. Third one, democratize the travel, making it affordable wherever is possible. The fourth one, now it has to become sustainable. Lowering cost is coming, therefore you have to make. Today, the 4th revolution enters on sustainability, representing a fundamental change in how the airspace industry operates. In addition to CO2 emissions, the sector is tackling contrails, which I will explain to you in the next slide, which is only when you fly in the humid regions, you will get water crystals on the, that is called contrails. Therefore, you need to, because of the weather data, you will be able to predict the humid region and the pilots can avoid, so that you will be able to do that. Now, this is the one, what is contrail? When a plane flies through the humid area, the shot from the exhaust can sometimes nucleate small droplets from ice. This is called cocktail. And the environmental impact, 55%, 55.9% is carbon, and 35.3 is the contrails. Nitrogen is 8.8. Now coming back to that sustainable aviation fuel, this is the future fuel. There is no way the current aviation fuel will stop in a matter of 20 years or 30 years. This is the ultimate goal. What they do is they take the used cooking oil and the forestry waste. All the feedstock is collected and as a water waste, and then they convert it into sustainable fuel, and it is taken into the jet fuel and fuel into the tank. That is what they do. Sustainable feedstock such as field corn is grown on farms. Other feedstocks are collected such as used cooking oil, animal fat waste, and certain household waste that normally ends up in a landfall. The feedstock is then processed to remove impurities. And then that is used to ethanol. This ethanol is processed into a product that is chemically identical to aviation fuel. Then the sustainable aviation fuel is blended into aviation fuel at 50/50. Now they are planning 50/50, not 100%. One of the difficulty is cost is prohibitive. Even though it will produce to 80% lower than CO2 life cycle compared to, it is definitely going to achieve that fuel emission part of it. But what are the problems? The normal fuel is 2.10 per gallon. Now it is 4 times more. And enough, it is not being manufactured. Therefore, this is going to be addressed by the aviation industry stakeholders, how to make sustainable availability and the cost. Those are the two elements which will be able to achieve the SAF. Now, alternation, Airbus is already on the plan to have alternate fuel. That means they go into zero emission with hydrogen. Hydrogen fuel cells will be installed to create electrical power that complements the gas turbine. This is the Airbus goal. They're going to plan it in 2035. The Airbus is planning to develop this and put it into service. This is more than about another, you can say 11 years are available. Also, hydrogen. And some other electric. Now the next one is electric. Multi-electric motor turboprop. Range is 1,000 miles and 100 passengers it can carry. It is being also planned. Same thing, turbofan, 2,000 miles also is under Airbus is already on the job to provide all this wing design. Now what I am trying to tell you, sorry, India is also in the plan. This is okay, I've done. Okay, here. This is the first Pipistrel has developed the internationally certified fully electric powered aircraft. Right now it can fly for 1 hour, but it cannot be used cross country. A to B it cannot go because it has to go on a controlled flight. Cross country flight cannot go. Only training pilots training can be used in a 1 hour to 2 hour duration. This particular aircraft has been approved by the American authorities, FAA, for the training flight. Second one is US-based Jolly Aviation developed 6-rotor all-electric vertical takeoff and landing. Electrical vertical takeoff and landing. That they 2022, it has been certified already. They have already operated 1,500 flights, accumulated more than 33,000 miles. In US, it can carry about 5 seats, about 5 passengers. 150 miles is the range. And now, Sarla Aviation in Bangalore is already on the job. 7-seat vehicle with up to 160 kilometers. The range is 160 kilometers. And Bangalore Airport and Sarla Aviation already planning on this. It will take 3 years because the regulatory approval has not yet come. And to attain the approval, testing and all, this particular aircraft of Sarla Aviation will take at least 3 years after getting the DGC approval. This is the Hyderabad-based company. Blue Arrow showed hydrogen electric vertical takeoff and landing. This range is 300 kilometers and 500 kg is the weight of the aeroplane, and the payload is 100 kgs, maybe about 2 passengers, 3 passengers. This is the this aviation, Bhuj Aviation. And first hydrogen, they are planning first cargo in 2026, after which only they will anticipate flights carrying between 3 passengers or 4 passengers, 2030. Right now, 2026, they are testing with cargo. This is US based already in the service. As I told you, each aircraft will carry 4 passengers, a pilot up to 160 kilometers. Next, move on technical. What are the technology trends? I'll just completely stop. This is the one of the things which is going to revolutionize the aviation, artificial intelligence, which every one of you know. Second one is autonomous aircraft. Third is 3D printing, which I will just show it to you. Biometrics already been implemented. And last is virtual reality training is on the way. Now, this artificial intelligence, it allows the computers to learn and solve problems almost like a person because it answers everything. Artificial intelligence and machine learning algorithms are revolutionizing aviation, emphasizing everything from flight planning and scheduling the aviation maintenance. And this technology, because of the data available and what are the winds available, what are the wind conditions prevailing, what are the turbulence area, everything the artificial intelligence is able to provide the data based on which on the ground, flight dispatcher will be able to select an optimum flight route so that the pilot will be able to save flight time and fuel also because of the data that is being supplied to the flight dispatchers. Artificial engine powered system to bolster safety and situational awareness, analyzing vast amounts of data, actionable intelligence, pilot and air traffic controllers does wonders with air traffic management. This transformation not only changes operational efficiency, but also elevates overall safety. These are all the things. And this is the smartphones already we are seeing. And this is the chat GPT already come in 2022. And Telstar autopilot is already started, self-driving vehicles. And the Waymo is the new one, fully autonomous since early 2022. Fleet rollover now fully electric. These are all the examples of that. Aircraft condition monitoring, because artificial intelligence will be able to generate work cards. What are the parts which are deteriorating over a period of time? Automatically, it will tell the maintenance people, create a new work card to repair this. Similarly, automatically, it will order spares. What are the spares which is completely, you don't have to wait somebody. It will automatically order the spares because it's continuously monitoring the spare supply. Visual inspection also, it can be done. Boroscopic inspection and visual inspection. If you see it here, you will be able to see the drone. Minute, any crack is there or not, we'll be able to identify using the artificial engine powered visual inspection. Maintenance data, spares provisioning, maintenance slot planning, and component usage. These are all the 3 maintenance activities that can be done. This is the Air India's one. Flight planning, customer service, airport management, artificial intelligence airline industry. This is the future possibilities, reduced or completely pilot-free operation. Here I want to tell you one thing, that when I joined in 1966, Air India had 5 men in the cockpit. Commander, co-pilot, flight engineer, navigator, and the Moscow sector radio operator, FRTO. When 1970, when the 747 came, navigator was removed because the inertial navigation system came. In 1980, when the Airbus flight management system came, flight engineer was removed. Finally, it became 2-man aircraft. Then somebody has asked me in the Human Factors Conference in 1982, what will be the future aviation, automation as scripting? Somebody answered, the future cockpit will have 2 people. One is the pilot, other is the dog. Somebody asked, why dog? The pilot job is to sit tight. He should not touch the control. The function of the dog is to bite the pilot if he touches the control. That is the kind of automation that they're expecting. But with my experience, I can tell you, no passenger will travel on any commercial aircraft if pilot is not in the cockpit. You can say anything. That is my philosophy. And still I'm going to say one more. 2 pilots are always will be there. Because one person today may not be able, long flights, 18 hours and 19 hours flight, something happens, you will not be able to control. Therefore, though they are telling pilots of the aeroplane will come, I do not know, I'm 83. I will be able to see or not, you will all be able to see. But definitely, the commercial aircraft will continue to have one commander and one co-pilot. Maximum they will do maybe one pilot. I do not know. That we'll see. Robotic ground handling, all these things, future possibilities of airport. Tomorrow, unmanned cargo aircraft. These are all certification by European Civil Aviation. The pros and cons of the artificial cost saving potential is there. Continuous improvement, increase efficiencies, poor data leads. Most important thing, potential cyber security, potential for sabotage is the data. Therefore, these are the consequences. Too much reliance on artificial intelligence with no backup is not a good thing. Yeah, artificial intelligence is also immune to unplanned events. You will have this only. You can't help it. Autonomous aircraft is already there. Already I have told you about that. The most important thing in the automobiles is regulatory approval will have to take a longer time. It's not easy to get regulatory approval. Therefore, industry has to work out to convince the regulatory authority that autonomous aircraft will not dilute the safety. Till such time, it will take longer time. More test flights are required. 3D printing, I've already come on. I'll only show you the parts, which are all the parts which are likely to be 3D printing. Now the industry says 2.8 billion was 2024. In next 5 years, it will go to another 1 billion more. That is the investment that you are going to see in the 3D printing technology. Less weight. It is easy to functionally integrate. Production planning schedule for arranging the aircraft schedule and the maintenance checks will be easy. And industry compliant materials will only be used. Lower CO2 emissions. Significant cost reduction because of the 3D printing. Biometrics I've already covered. I don't know. This virtual reality training is on the move, and majority the pilot simulator is going to be used on using full flight simulators for the pilot training. Better ramp handling and more efficient assembling process, enhanced communication and convenient data access and faster wiring. These are all the advantages of that. Future challenges, regulatory authorities will need to work. Ultimate goal is to increase efficiency. Sustainable aviation waste limitation due to availability and cost, I told you. New engine technology also increasing the cost. Innovation in the wing design will require significant airport structure. That's very important. End of life issues remains for carbon and battery technologies. Because when you have a battery, the electric aircraft and all, battery technology has to be completely improved. All the airport must be fully available to provide the battery. Artificial offers huge leaps in innovation. And we need a TFIR for aviation safety and efficiency. One is technology, innovation, and we have to focus. And finally, the resources are required. This is the final summary of that. Because of the time, otherwise I will be able to. Any questions is there, I'm prepared to answer because I wanted 10-15 minutes for that.
No, not at all. Thank you very much for a wonderful lecture, sir.
Yeah, thank you, sir, for the wonderful presentation. So I just want to know that as we were seeing that navigation is getting more and more satellite based. So earlier, like a few months ago, I was seeing a video that one aircraft was flying at 30,000 feet. Suddenly, the GPS signal got spoofed, and they were getting EGPWS.
No, I'm not able. Just
yeah. So like it was flying at 30,000 feet, and it was getting an EGPWS warning that
EGPWS enhanced ground proximity.
Yes. So it was getting a warning that terrain pull up.
Yes.
But the aircraft was 30,000 feet, so obviously there is no terrain there. So like. But if this kind of spoofing happens at much lower altitude,
yes.
So what is the problem? And then the second question is that if
the terrain base of all the airports, when you are flying on a route, is available in the computer. All the terrain bases of the airport, let's say from Bombay to London, what are all the terrains throughout the route is available to me in my database. When I'm actually, as you correctly said, when I'm approaching to land or I'm diverting at that point of only, or every point, supposing if you're operating, let's say Delhi to Tashkent, all the Kabul and all this thing, 20 Himalayas and all 20. Therefore, the safety height of the flight depends on the terrain. We always keep a safety height 2,000 feet above the terrain. When the pilot flies, if the terrain is 7,000 feet, he will fly 9,000 feet below 5,000 feet. Above 5,000 feet, he will always maintain 2,000 feet above the terrain. Below 5,000 feet, he will keep only 1,000 feet terrain when you fly. Therefore, when they're very close to terrain, he will get the warning because of the enhanced GPS already available to him. On the basis of that, he will take the action.
Yes, but as I said, there is a spoofing, jamming and spoofing of GPS signal. So if somehow you spoof the GPS signal, if the aircraft thinks that it is in much lower terrain, but the terrain is higher.
Jamming has happened,
Yes.
but you can't help it. At that time, he will take whatever possible at that point of time, and he will take a possible reversive action. In case if it fails, then we have to meet with eventuality. Yes, jamming has taken place.
Yes. So if other forms of navigation like VOR, DME or NDB, if those ground-based, can they also be spoofed or jammed?
Yeah, that is totally eliminated now. DVO, DME and all is completely gone. All satellite communication, GPS, most of them performance-based navigation, which is called PBN. Approach landing is 0.05% they are doing it. Therefore, VOR old concept in the it's no more. Many of the places VOR, DME is all being discontinued.
Okay.
They all become performance-based and satellite-based navigation.
So thank you very much for a fantastic talk. I've just looked at that Saral, or the aircraft you said from being manufactured in Bangalore. That looked like Osprey design, isn't it?
Is it?
Osprey, the American military defense has Osprey, which can go up like a chopper and then go, that looks like Osprey technology.
The one which you saw Bangalore, yes.
Okay. Is that, I think that stability of that system is still under lots of discussion, right?
Correct. But that is why I'm telling you, it will take at least 2 years or 3 years to demonstrate to the regulatory authorities that they will be able to meet the guarantee of safety. Number one. Unless the safety is guaranteed, they will not get the approval.
Okay.
Because they have projected 3 years, and at least they have to do 75 test flights.
Okay.
They have to test and prove it. Then only, that's why they have given a period of 3 years. If they're able to achieve that, they will be able to expedite the approval little earlier. First, they will try it as a cargo aircraft, as you correctly said, before putting a passenger, three passenger, 2 passenger, whatever it is. First, they will try with the cargo, how it is going to operate. And then based on that, they will develop.
One more follow-up question.
Yes,
so
sir.
this is about, the GPS that might have definitely improved, the efficiency and the safety and all that. But how much is, it's because we are now developing local GPS, that Indians have, Chinese have. So is that
India is also Gagan has come.
correct?
Yes.
How important those modification, the additions are?
See, no. The Gagan, the introduction of Gagan has reduced our dependency on the other satellite. If they jam it and fail it, we have got an alternative one of the Airport Authority of India, which is developed, that they will be able to use. But when you go to other places, naturally you have to depend on that Russian this thing or United States SATCOM or whatever it is. That is the local government has to ensure that the satellite availability. If the satellite availability is affected, naturally the flight flying on that region will have a communication problem. Then they will have to degrade their performance level. Accordingly, they will take extra fuel or to go the longer distance or whatever it is, depending upon the satellite availability. That will be given in a NOTAM. The notices to airman is always issued to the pilot before a flight. The flight dispatcher has to analyze what are the notices to the airman which has come from various countries on the route on which he flies. Supposing he finds that, then he will try to take follow-up action from the briefing itself. They will tell, here the satellite communication is not available. Therefore, you may not be able to use 100%. Use HF or VHF.
Okay. So the all systems.
Yes, that's all. That frequency is always there for the pilots.
Okay.
He has to use an HF and VHF, but it will have a limitations of little extra time or whatever it is, the communication because of that. Maybe 20-30 minutes will be delay the flights.
Okay.
Because of the inaccurate information which is coming through the other sources.
Thank you very much.
Yeah, this is regarding this with so much of safety availability right now. This MH370 Malaysian Airlines, Malaysian Airlines MH370.
Malaysian Airlines,
So
till today, they are not able to find out because no data available. Because they are now what they are telling as a result. One of the beauty about aviation is Any accident takes place, they immediately take a corrective measure to prevent the future. Now, therefore, what they are doing it, today they are going to install, instead of CVR and DFDR, they want to have one kind of system where in the, let's say Bombay, I will have the airport, let's say 10 flights are going out of Bombay. All the 15 flights, I will be able to monitor each parameter with a system within my sitting in the room only. There, ICAO is addressing that issue. That will take 1 or 2 years more or 3 years more, so that all the airlines will have to install that system in there, so that they will be able to monitor their aeroplane. Now, if you ask me, Emirates is operating 1,000 flights. Whether all the 1,000 flights will be monitored by them, how many manpower is required? But this is a real mystery. Some people are saying it's sabotage. It's deliberately been shot down or whatever it is. But they are not able to find out any clue on the CVR and the DFDR is not there. It's a conjecture. That is one of the mystery of the aviation accidents. Till today, nobody, and already they have paid 75% of the insurance amount to the majority of the people are affected. People are demanding another $1 million more, but the Malaysian authority and other people are fighting with the legal battle how to resolve those also, because they have not had the evidence that it was lacking Malaysian Airlines, what do you call, responsibility. They are not able to fix the responsibility for the accident to the Malaysian Airlines itself. That's why the 25% of the claim is still unsettled.
Thank you for the wonderful talk. Sir, technology is there, accidents have come down, everything is nice. But is there any way to reduce the delays? Often these flights are never come at time, never take off at time. 1 hour, 2 hours waiting is become very common these days. So is there any proposal or any technology, or what is the...
There is no technology, sir.
No, what is the reason then getting delayed?
The reason, see, this is, let's say, the aircraft is coming with a small snack, very small snack. They say 40 minutes, the maintenance people tell, no problem, we will be able to put. When he opens the snack, he finds another system is fault. But one of the thing is, he cannot allow the system to go just because I'm on time. Therefore, he opens, that takes another one. I'm talking about the maintenance part of it. Therefore, some passengers, baggage, now today, baggage is, supposing the conveyor belt is thinking something is not working. Computer system was not working in Bombay airport, and 2-3 airports internationally also, the booking people are delayed. So delays cannot be completely avoided. Weather delays, ATC delay. Now today, every flight in Bombay, I myself is saying 30 minutes, 25 minutes delay, because Bombay is accommodating, let's say 40 aeroplanes in the evening. They are given 70 aeroplanes arrival. But all the 70 arrivals come, 20 departures are going. No airplane is going on-time departure because of the ATC. Because Bombay airport is fully overcrowded. They want that delay is ATC delay. You can't help it. Therefore, some of the delay is passenger delay, weather delays. On our own, one aircraft says Bombay to Delhi. Already production planning as the Bombay Delhi airplane will come on time. It will go Delhi to Bhubaneswar. But if Bombay Delhi is delayed, Bhubaneswar is also delayed, and Bhubaneswar connected, that finally the duty time of the pilot takes place, then the entire flight will be collapsed in particular. Therefore, this is the complex issue of flight time, duty time, maintenance checks, all those things are involved. But normally, every airline wants to give 100% on-time performance. But they are not able to get 100. They put 80 to 90. Some people say 5 minutes delay, 15 minutes delay. But delays like fog, that's people are qualified on 3. But suddenly the pilot reports it, you're on getting a 3:30 flight, he is not able to land, 2 hours of delay. If the fog delay comes back, the entire chain of delay takes place, because the same aeroplane supposed to come from Delhi on time is supposed to go to Madras. Therefore, the whole system is affecting because of the production planning. The same aeroplane is coming. Delays cannot be avoided, but it can be only minimized. And some airline takes priority that I will, let's say, during the Delhi winter months, all of them are change the departure time. Morning, 6 o'clock to 7 o'clock. Therefore, they delay the departure itself in Bombay, so that 11 o'clock or 12 o'clock, the possibility of diversion at Delhi because of fog is less. Therefore, they are able to do that. that delays cannot be completely avoided. But airline is very conscious because on-time performance is one of the weapon for the commercial people, for the airline people to attract the passengers. Air India flights always delayed. I don't want to go. Like that people say. But the same, I don't want to come. He will shout. Next day he will be flying only Air India airplane. Only in the counter he will say, because the Indigo also like that. Therefore, it can't be avoided.
Thank you very much once again. I think we have time to go. The questions can go further on a tea.
Yes, sir.
Everybody is welcome to join. Thank you very much.
Thank you, sir.
for being available.
Thank you very much.